the galaxies, the solar system, our home planet Earth. Land, sea, air, life. Where did they all come from? Look up into space from our planet, and what you see is a vast cosmos, teeming with billions of stars and galaxies. Turn back the clock over 13 billion years, and our universe was a very different place. In the beginning, there was nothing. No space, no time. And then there was light. Suddenly, a tiny speck of light appears. It was infinitely hot. Inside this tiny fireball was all of space. This was literally the beginning of time. The idea that our universe was once tiny originated from the brilliant work of American astronomer Edwin Hubble. Back in the 1920s, most astronomers believed that everything visible in the night sky were stars, and they were part of our galaxy, the Milky Way. But Hubble wasn't convinced. He studied a swirling cloud of light called the Andromeda Nebula and showed that it was a star city, another galaxy, far outside of our own galaxy. He showed that these other galaxies were speeding away from ours, and the further away they were, the faster they seemed to be moving. The universe was expanding. And if the universe was expanding, then at some point in the past, it must have been smaller, much smaller, and that it must have had a beginning. Theoretical physicist David Spergel is a Big Bang expert.
We don't know how the universe began. So we start our story when the universe was a billionth of a billionth of a billionth of a billionth of a minute old.
No one knows exactly what happened during the Big Bang, but scientists do know that a fraction of a second after the universe was born, this tiny, super hot fireball was already starting to expand. In the same way that this hot glass ball inflates, so did the baby universe, expanding in all directions at once. And as it expanded, it cooled. A trillionth of a second after the Big Bang, the universe was small enough to fit inside the palm of your hand. A tiny fraction of a second later, it was the size of Mars. Another fraction of a second, and the baby universe had grown to 80 times the size of the Earth. One of the scientists who discovered this critical moment in the story of the universe was Arno Penzias. 1963, 30-year-old Penzias and his 27-year-old colleague Robert Wilson began work on a new antenna in New Jersey. Initially, they were only studying cosmic radio waves, but they would stumble on one of the greatest discoveries of all time. As they started to test their equipment, they detected an unexpected background noise.
It was additional signal, and it appeared to be coming from the sky. We eliminated very carefully the ground, even the solar system, because we did this winter to summer, seasonal variation, man-made sources of equipment. All these things were eliminated.
In desperation, the two scientists began to wonder whether the strange signal might have another, more earthly origin. They found there were pigeons roosting in the antenna, and it was covered with droppings. They wondered if the pigeons were the source of the strange signal. There was only one solution. The droppings and the pigeons would have to go.
We finally got around to removing the pigeon droppings. We also had to remove the pigeons. That was a difficult problem because they turned out to want to come back, and we mailed them off to another site.
But even with the troublesome pigeons gone, the mysterious signal would not disappear.
And so we were left with the almost inescapable conclusion that this radiation was coming from the sky.
The strange signal detected by Penzias and Wilson would turn out to be one of the most important scientific discoveries of all time. But the explanation for their mystery background noise starts not with sound, but with the birth of light. We usually take light for granted, but in the early universe, 13 billion years ago, we would see nothing at all. Light was trapped. The universe was foggy. But as the universe continued to expand and cool, the electrons slowed down. Protons then grabbed these calmer electrons to form complete atoms of first hydrogen and then helium. The universe was suddenly much less crowded with electrons. The fog lifted and light was no longer trapped. What they heard was the quiet echo of the moment the universe formed the first atoms. Carlos Frank has created an amazing 3D simulation of how the early universe evolved. It shows that when the universe emerged from the Big Bang, it was uneven.
Little cracks appeared, which were very, very, very tiny, very, very small. And it was this rush in the face of the baby universe that later developed into the patterns that we see in the galaxies today.
Without these cracks, the universe would have been a very dull place. The first clues as to how these cracks developed into galaxies and stars came when other scientists started to examine the Big Bang radiation first discovered by Penzias and Wilson. These tiny imperfections in the fledgling universe would become galaxies and stars.
And this is one of the most amazing propositions in physics. The idea that galaxies like a Milky Way that contain 100 million stars once began life as a tiny little crack in the fabric of the universe.
Over millions of years, the hydrogen atoms clumped together and heated up. The atoms began fusing and releasing energy, and the gas clouds started to burn brightly. Eventually, a star was born. All over the universe, millions of stars ignited for the first time.
The appearance of the first stars would have been a truly spectacular event. Had we been there, we would have really seen fireworks, individual enormous flashes of light generated as the stars are born and burn themselves out.
These young stars were nothing like our own sun. They were very unstable. But it was their instability that would make the universe a more interesting place, because deep inside each new star, something amazing was happening. They were creating new elements. The idea that stars build atoms came from the British astrophysicist Sir Fred Hoyle. Hoyle wanted to know where the elements heavier than hydrogen and helium came from. He figured out that stars acted like nuclear reactors, working a bit like a hydrogen bomb in slow motion. But many billion times more powerful, and their nuclear waste was new elements. Scientists then examined the spectrum of light from these distant stars and showed that these early galaxies had already created elements heavier than hydrogen and helium, one after the other. 3 helium nuclei combined to form carbon. 2 carbon nuclei fused to form magnesium. Magnesium to form neon, and so on over a period of hundreds of thousands of years, until silicon fused to form iron. Tony Metzacappa from Oak Ridge National Laboratory in Tennessee believes that without exploding stars, life itself would not exist.
Life as we know it certainly would not exist were it not for core collapse supernova events. They are very clearly one of the key links in our chain of origin from the Big Bang to the present day.
والنجم إذا هوى ما ضل صاحبكم وما غوى وما ينطق عن الهوى أنزلنا الحديد فيه بأس شديد
ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار سنريهم آياتنا في الآفاق وفي أنفسهم حتى يتبين لهم أنه الحق أولم يكف بربك أنه على كل شيء شهيد ألا إنهم في مرية من لقاء ربهم ألا إنه بكل شيء محيط